Good morning, lovely humans. So today we are going to be doing a review of sequences. So this was something that was covered in Algebra 1, but I think it would be good for us to get a refresher. So we will go back and understand what's going on with these things called sequences. That is because we are going to be moving on to chapter 10, and we're going to be talking about series, which rely on you knowing a lot about sequences. So during this time, take some notes for yourself, whatever is helpful for you. So what is a sequence? So a sequence is a list of numbers that follows a pattern. It's a lot like a function. It's a type of function, but the domain, so the values that you can put in, are only whole numbers, or natural numbers, I should say. So the numbers 1, 2, 3, 4, and so on. This makes the graph special because it ends up being a discrete graph, just single points. So to highlight this fact, there's like this whole set of notation that mathematicians use called AN, which you can see here, or T of n. So you probably are more familiar with T of n. That's what Algebra 1 teachers usually focus on. Today I'm going to be focusing more on A sub n, or AN, just to expose you more to it so that way you can get a little bit more used to it. So the types of sequences that we've worked with were arithmetic, not arithmetic, arithmetic. And they grow by adding and subtracting. So this one here, you can see that it's growing by adding 4 each time. And then geometric grows by multiplying and dividing. So in this case, we are multiplying by 3 to get from one term to the next. And then there's also some sequences that can only be defined recursively. So one example that you probably looked at was the Fibonacci sequence, which grows by adding the previous 2 terms to get the next one. So for example, to get this 4th value, we took the 2nd term and the 3rd term and added them together. So what's kind of confusing is that there are... Why won't this thing go away? There we go. What's kind of confusing is that there are equations that you can write that are called recursive equations. But what's special about a recursively defined sequence is that it can only be written with a recursive equation. So for Fibonacci, there's no way to write any other type of equation besides one that relies on the previous terms. All right, so before we get started, we definitely have some vocabulary that we need to get squared away. T of n, or an, is going to be the nth term. So for example, if I say a1, I'm referring to the first term. If I say a10, I mean the 10th term. N refers to the term number. So if I say I'm looking for n equals 5, that means that I want the 5th term. Common difference, I'll use D to refer to the common difference, and that is what's added to get from one term to the next in the arithmetic sequence. Notice that if we are decreasing, then our common difference will be negative. So you're still adding a negative, and that's kind of a slight nuance just to make sure that you can have a positive or a negative common difference. Common ratio is what is multiplied to get from one term to the next in a geometric sequence. It's generally more helpful in the equation to look at the ratio as something that you're multiplying by. So even if you think you're dividing by 3, you want to think about what you can multiply in that case to get the same result as dividing by 3. So in this case, if you're thinking about dividing by 3, you could write that as a multiplication by 1/3. Finally, we have our 0 term. We say T of 0 or A0, the term that would come before the first term in a sequence. So we wouldn't graph it. It's not actually part of the sequence, but it can be helpful for writing the equations. So again, I think I mentioned this earlier, but you were going to be seeing me use mostly an minus 1, an plus 1, just because I think that you were mostly exposed to T of n, but the book is also going to be looking at an. So just know that they are the same. T of n means the same thing as an Mathematicians are weird. So we're gonna be looking at two types of equations for sequences. Explicit, so those, if I give you n, then you can find the nth term, an. And then we're also going to be looking at recursive equations, and these ones are equations that relate whatever term comes next to the previous term. So an, what comes before an, that's going to be an minus 1. So it says, let's take an minus 1, let's do something to it so we can get the next term. So let's look at equations for arithmetic sequences. The general form is really similar to the equation of a line because they grow at a constant rate. But just to be extra fancy special, they use this notation. So an equals d times n plus the zero term, a0. The book also likes to use first term form, and we're going to prove later that these are equivalent. They're the same thing. But if you do an equals d times n minus 1, and then you can add the first term. And those will be equivalent, so just be on the lookout for that. You can also look at recursive equations, and people get really messed up and confused about these, but I actually love recursive equations because despite their confusing notation, they're actually the most intuitive. All a recursive equation says in fancy math speak is to get to the next term, take the previous term, and add your common difference. And then it tells you where to start. So in this case, it says to get to the next term, take the previous term, and add whatever you're adding. By the way, here's where you start. Notice there are two ways to write recursive equations. You can think about them in terms of n plus 1, and then the term before that, which is n. You can also think about n and n minus 1. As long as they are next to each other, right? All it's saying is that to get to this term, what came before it? Okay, let's add our common difference. So let's look at an example. So here we have our sequence 13, 8, 3, negative 2. You might notice some stuff about it. For example, it goes down by 5, so our difference is negative 5. The 0 term, we're going to go backwards from 13, right? So the term that would come before that would be 18. And then we will take our a1, which will be helpful for the recursive equation and first term form. We just look at the first term, which is 13. So I just wrote the basic explicit equation and recursive equation, so you can pause if you'd like and try to fill it in. So for our explicit equation, we fill in our common difference and our 0th term, so we get an equals negative 5 times n plus 18. If you want to check that it works, you could try plugging in, let's say, n equals 3. Oh, that's confusing. Let's do n equals 4, right? So let's plug in n equals 4. To get our 4th term, we're trying to get negative 2, so n equals 4, that will be negative 5 times 4 is negative 20. Negative 20 plus 18 does indeed make negative 2. To write it in first term form, we just shift it over. So we're going to start at 13. And then instead of multiplying by n, we'll multiply by n minus 1. Notice that if you actually expand this out, you will get the exact same thing as the 0 term form. So if you multiply this out, you would get negative 5 times n, which we have here. You'd get positive 5, positive 13, which makes 18. So equivalent things, but some people prefer first term form because they don't have to calculate the 0 term. For our recursive equation, go ahead, try it if you haven't. You should pause to try it because I'm going to move on. So you have an plus 1 equals an minus 5. Notice you don't fill in n. The only thing you change is what you're doing to the previous term. So in this case, I chose to use the n+1 and n combo, but you don't have to. You could have also done it with an and an-1. I'll show that for the geometric sequence. And then with recursive sequences, you do have to say where you start, okay? So there's lots and lots of sequences that to get to the next term, you take the previous term and subtract 5. I could have started at 100, I could start at 50, and I can still go down by 5. So that's why it's important that you include that first term so the person looking at the equation knows where to start. Okay, so we have our explicit equation for geometric sequences. They are similar to y equals ab to the x. To write the equation, we just say an instead of y, we say a0 instead of a, and we say r instead of b, and we say n instead of x. Don't you love sequences? And then similarly to arithmetic sequences, there is this, can I have a pointer? Yeah. There is the first term form where you kind of shift it back one and start at the first term. The recursive equation is the same idea as it was for arithmetic. So to get the next term, you take the previous term and then multiply by your common ratio. And you have to specify where you start so the person knows where to start, or else they're just like, okay, that's great. I subtract 5, but what's my first number? So here we have an+1 equals the common ratio times an. So that says to get the next term, take the previous term and multiply by r. And we can also relate it to n and then n-1, right? We'd still have these values that are next to each other. So we're still saying that to get to the next term, take the previous term, multiply by r. All right, so geometric sequences, I gave you a tough one because we are in big kid math now. So we are going to look at 15, 12, 9.6, 7.68. If you would like to try this on your own, click pause now. So we have, to get the ratio, we want to divide 12 by 15 to figure out what we're multiplying by. So the second term divided by the first term. And so we get 0.8. So to get the 0 term, we want to do 15 and then divide by that ratio. So we'll get 18.75. And then we can just look and see that our first term is 15. All right. So where were we? And then we also can write it in our first term form. So 15 times 0.8 to the n-1. Then we have our recursive equation. So to get to the next term, we take 0.8 times the term before it. This time I chose to use n and n-1 just to show you what that looks like. And then we have our first term. So yeah. And that is all I have for you about sequences. So hopefully that refreshed your mind about what those sequences are. There will be a review packet coming for you for Friday.